Okay, so far we were solving the problems based on the graphical technique, and let us try to solve another problem on the graphical method. This is for the given VT graph. Obtain obtain the ST graph at t equal to 0, s is equal to 10. This is the given VT graph. This is 2, 2, 4, 6, 10, 12, 16. 2, 4, minus 2, minus 4, minus 6, minus 8. So the graph is given like at 2 it is 4, at 4 is 0, at 8 it is minus 8, at 12 it is still same, and at 16 is 0. All right. So the solution begins like this. Let us say we want to draw the distance or the displacement versus time. So every second, at the end of every journey, I have to find what is the displacement, right? So I see that the velocity is a straight line, right? So because of which I can simply apply v is so distance is equal to velocity into time. Okay, so v into t gives me the distance or the displacement. S is equal to simply vt. I can do that because a is going to be 0 as the velocity graph is a straight line. So everywhere it's a straight line. Because of that, you can simply apply this. If at all this was non-linear curve, then it means there is a acceleration coming into picture. But as of now, acceleration is not there, so I don't have to worry about that. Simply apply displacement is equal to velocity. What is the velocity into what is the time duration? So uh, 0 to 2 seconds is my first time duration that I'm going to consider from the above said graph. From this graph, I can see that this whole motion is divided into uh, different parts. One is 0 to 2, another one 2 to 4, then the third one is 4 to 8, the next one is 8 to 12, and 12 to 16. So many parts are there, so we have to calculate every term as part by part. All right, so let us start. So t is equal to 0 to t is equal to 2. In this particular duration, what is the distance covered? It's a positive, so I know that velocity is positive means the displacement is also positive. So I will call this is displacement S1. Okay, I'll call this is S. S corresponds to the distance covered during this time. So S is equal to, it is V into T. Okay, so I can see that it's actually right. How to find out the displacement or the distance from the if the VT is given. So we have to refer our table. Earlier we had a table. How to find out what is given, what to be found, right? So velocity time is given. My intention is to find S. That means I have to find the area. So simply find the area under that curve to get the distance covered. So I can see that I have to find only this area, right? That is half of this total area, correct? So length is 2, breadth is equal to 4. So the area of that rectangle is 2 into 4. I need half of that, correct? So the area of that triangle is, you can use half into base into height. That's also half into 2 into 4 is 4, right? So velocity into time is nothing but 4. But what I want, I have to add this to the initial, correct? So this is the displacement during that time, but the total displacement is what I am supposed to plot, correct? So I can write S total is, if you have an initial value, that 10 plus this 4, so totally it becomes 40. At the end of how many seconds? 2 seconds. The displacement that I need to plot on the graph is 40. It begins at 10, it goes till 14. Let's see the shape of the curve later. No problem. Then, right, I have to see if, okay, let's write the shape of the curve here itself, so that when I plot it becomes easier. So you can see the straight line, velocity is straight line. So I have to go back and check what is the displacement curve looks like. Velocity is linear. You can see this is the curve. Velocity is linear, right? Or this. I can see that the displacement will be, right, like this or this, right? So that's what is my curve. It's non-linear increasing. Increasing, and this is non-linear because original distance, previous distance was 10 and now it becomes 14. It means it has to increase. That's why I wrote increase. All right. So if you have doubt what is the given velocity time graph and how to convert that into the S displacement graph, I know that from the table it has to be it has to be the integration, which means it is the area under curve. So I found that area, I calculated and I got the answer. And the next part is what shape it is. Already previous session we have discussed about what shape should be considered for what type of motion, right? So we are using that to decide this. So this is between 0 to 2 seconds. Then the next part of the curve is actually t is equal to 2 to t is equal to 4. I can see that the velocity, right, is slowly decreasing. Okay, but since it is above, I can consider that to be the positive. Since there is on the positive side, velocity is there, velocity is coming to 0, right? Velocity will be 0 at the end of 4 seconds. So I can conclude that the vehicle still moves ahead only. Vehicle is not returning, not coming in the negative x-axis, it's positive x-axis. So because of that, it is still positive because the area is positive. So this is once again S equal to distance covered is equal to displacement is equal to velocity into time. So I am right now calculating this area. So right angle triangle half into base into height, that comes to be once again 4. Since this area is positive, so positive area means it is above x-axis. If the area is below x-axis, that area is considered to be negative. So the velocity is also going to be negative in such cases. But as of now, it is positive. So Vt, that is equal to once again 4. So what is the distance covered now? S total is equal to previous value, that is 14 plus 4. So that is equal to 18. Once again, if the velocity is decreasing in shape, but on the positive side, right, the displacement is still positive and it is increasing. Okay, so this is increasing non-linear. Okay, that is 2 to 4. Then now you see I want to calculate 4 to 8. So basically 4 to 8 refers to this area in total. Okay, so that area can be calculated as half into base is how much? 4 to 8. So that is base is 4 and the height is 8. So half into 4 into 8. Okay, before that let me write. So t is equal to 4 to t is equal to 8. Right? So S is equal to velocity into time is my equation. But you see, velocity into time gives you the value half into base 4 into 8. So that is basically equal to 16. But you see, this is actually negative. Why it is negative? Because it is below the x-axis. So I'll write a minus here and minus here. So this is minus 16. Below the x-axis, area is negative. Just now we discussed. So as per that rule, this area comes below the x-axis. Hence, it is negative. Okay, so S is equal to total value. Let us calculate. So S total is equal to, right, the previous value to this value I should add. So previous value is 18 and the current value is minus 16. So that is 2. Okay, so everything is in meters. So that is 14 in meters, 18 in meters, and now 2 also in meters. Okay, then I want to calculate 8 to 12. So 8 to 12 basically refers to this area in total. It's the area of a rectangle, so base into height. So base is 4 and the height is 8. Okay, so this is between t is equal to 8 to t is equal to 12. So S is equal to V into T, but this area is negative, that's why this is minus 4 into 8. That is minus 32 meters it's going to travel. Alright, that's the displacement. So total displacement is, with respect to origin, if you are calculating, previous value is 2 and current value is minus 2. So this is going to be at position minus 30 meters from origin. Okay, now okay, the previous one, let's consider. We have not written what was this. So this is decreasing 18 to 2. So this is non-linear decreasing. Not a straight line. Okay, but now you see this 8 to 12 velocity is constant, right? So velocity is constant means even the displacement will be a constant. You can refer back to the graphs we had written earlier, where you will find that this motion is linear and decreasing. So 2 to minus 30, it's a straight line on the ST graph. All right. Later, the last part, that is t is 12 to t equal to 16. Right? The displacement, let's calculate first. That is normally velocity into time. But in this case, it is, let's go back to the graph and check. It's a triangle. So half into base is 4 and height is equal to 8. So 32 by 2 is minus 16 meters. It's going to travel. Okay, and we will note that the total ST is equal to minus 30 minus 16, that is minus 46 meters from the origin. Origin is considered as the mean position. Okay, so we got this. Again, you see that there is velocity means it is non-linear and decreasing. It is non-linear and decreasing. Let's try to plot this. So this is a displacement versus the time graph. Okay, and they have mentioned that it is time axis 2, 4, 6, 8, 10, 12, 14, and 16. And also, it is mentioned that we have the distances to be followed in the following fashion. So maybe we'll mark like 5, 10. So this is the positive value of S. Let's see how much we need to plot. So let me go back and check the values. So there is a plus 14 plus 18. So positive till 18, but negative I want till minus 46. So this is minus 5, minus 10, minus 15, minus 20, minus 25, minus 35, so minus 40, minus 45, minus 50. Okay, let's check now. So let's go to the first part of their result and let's try to find out what is the distance covered at the end of 2 seconds and what is the initial value. So they have given that there is an initial value in this graph to be considered. So initial, yeah, this one. There is an initial value which is given as s is equal to 10 at t equal to 0. So obviously I need to start my graph from here. This is the point where it starts, because at t equal to 0, that's the distance. Then you go one by one. At t is equal to 2, it reaches 14 and it is increasing in a non-linear fashion. So it has to reach 14 first. So 14 is here. At the end of 2 seconds, it has to come very close to 14. And you see it is a non-linear function. So that means this is going to increase in, okay, it's not a straight line, so it has to increase slowly and reach that point. Okay, so it's a non-linear function. At the end of 2, it has to be somewhere here, maybe 14. Not a straight line, okay, it's non-linearly increasing function. Then the velocity decreases 2 to 4, right? But it covers a distance of 4 meters, and you can see that increasing but non-linear. Now it will not increase in the same way as it was increasing earlier. It is in the opposite way. So from 15, maybe 18 is somewhere here. So it actually increases in the opposite in some other fashion. So maybe like this. Okay, so this is somewhat 18 and this is at 4. All right, then let's go further. After 4, now the next is a 4 to 8. It reaches 2 at the end of 8 seconds. So at t equal to 8, it has to reach 2 and it is a non-linear decreasing function. So let me go and mark the 2 first. At the end of 8, it reaches maybe 2 is somewhere here. And this has to be a non-linear decreasing function. So it will decrease something like this. Not a straight line. All right. So say is 2 around 8. Okay, at 8 it is like this. All right, next part, from 8 to 12. By the time the t reaches 12, it has to reach minus 30. And you know that this is linear and decreasing. It's simply a straight line. I just have to draw a straight line. And it has to take it to minus 30 at that time. So let's say minus 30 is this point. So it will be a straight line connecting this point to this. right? Then from minus 30, when the time is 16, t is equal to 16, it has to reach minus 46. So minus 45, maybe minus 46 is here, and time equal to, okay, say this is the time. And it is decreasing function, and it is a non-linearly decreasing function. So as velocity is reducing, initially the speed will reduce faster, and then it will come to, so it's a non-linear curve. So the time versus displacement curve will look like this for the given question. All right. So I will ask you one more question related to this itself. So I want you to calculate the average velocity of the particle for this given graph. Okay, find the average velocity of the particle for this given graph, or even this question, whatever they have asked, find the average velocity. If you want to calculate the average velocity, my equation, right, should be, let's try to write this. This is V average. Average velocity is nothing but the total displacement divided by the total time, correct? So I need to calculate the total displacement. That means S final minus S initial whole divided by the time. Okay, so time is very clear. The object is actually moving for how many seconds? For 16 seconds. 0 to 16. So I can directly write this as 16. Okay, S I have to find. Final value of S is equal to minus 46. Minus, what is the initial? Is 10, right? Right? It can be easily seen from the graph, divided by 16. So this is minus 56 divided by 16. So average velocity is continuously decreasing here. I think 48 plus 8. So this is minus, yes, minus 3.5 meter per second. So minus indicates that your velocity is continuously decreasing. Okay. All right. Now I will ask you another question in the same. I want you to calculate the average speed. So if you want to calculate the average speed, you are supposed to calculate the distance covered. That is the total distance divided by time. Okay. So there is a difference between the distance and the displacement. First, let's calculate. So this is average speed is equal to the total distance divided by the total time. So I have to calculate a distance now. Distance covered is without sign. There is no plus and minus. Plus and minus comes into picture only when you consider that as a direction, right? So plus is right side, minus is left side. This is what we considered as our convention, right? That's why everything become plus and minus here. But if you want to calculate the distance, right, you need to consider these values. First 2 seconds you travel 4 meters. Next 2 seconds you travel 4 more meters. Next, not minus 16, plus 16, and so on. So simply keep on adding all the values traveled in every second without considering the initial position. That is not required, right? So when you do that, you are going to get, right, the total distance. Right. So first 2 seconds it is 4, next 2 seconds also 4. Then it travels according to the displacement, it is minus 16, but for us it is plus 16. Distance wise it is plus 16 meters, that's all. Then the next few seconds it is going to travel minus 32, for us it is going to be plus 32. And last 2 seconds 16 meters. Whole divided by the total time is equal to 16 seconds. Okay, so 4 plus 4, 8, 16 plus 32 plus 16 is 72 divided by 16, right? So this is 4.5 meter per second. Okay. Okay, now let me add a part of to this question about acceleration. So my question is, find the average acceleration between t equal to 2 to t equal to 8. So I'm asking specifically between the time duration, that is 2 seconds till 8 seconds. Only that is required, not the whole acceleration. EA average is equal to, so final change in velocity. So how do you write the change in velocity? Something like say delta V by delta T. So delta V final minus V initial divided by change in the time. So again, the change in time could be final time minus initial time. Okay, so that can be, I'll write TF minus TI. So you see, they are asking between 2 to 8. So this is velocity at 8 minus velocity at 2. What is the final time? That is 8 minus initial time is 2. So just look at the graph and find out what is the velocity at t equal to 2 seconds. That is the given data, right? That is 4. How to find out? You can see that over here. Yes, this is the question. See here, this one. At 2, it is 4. And at 8, it is minus 8. Okay, so I'm supposed to make this calculation. V8, sorry, at 8, it is minus 8. And at 2, it is 4. Whole divided by 8 minus 2 is 6. Okay, so this is negative. Minus 12 by 6 is minus 2 meter per second square. All right. All right. Let me ask you another question. This is over. New question, right? So this is, if ST graph is given, find the VT graph. Ah, Okay, this is x, the displacement versus time. Yes is also fine, x is also fine. X indicates it's the direction, x-axis. Okay, so 2, 4, 6, 8, 12, 14. Okay, till 14, the displacement is there. Say this is -6 -8. This is 4 till first 4 seconds. Then at minus 10, this has to be minus 8. Okay, at 10, this is minus 8. At 14, this is 0. All right. So this is the displacement versus time graph. And the question asked is plot the velocity versus time graph. So go back to the table and check if x displacement time is given, how to convert that into the VT graph. What is the operation that you are going to perform? Okay, first check that. Then you try to solve. So I have to find, in order to get the VT graph, you are supposed to find the change in x divided by change in t, right? Okay, so this is actually pretty straightforward, right? Only when there is a change we get the answer in this answer graph. Okay, let's go to the answer graph. So okay, let's plot the similar time. Okay, between 0 to 4 seconds, right? If you want to calculate the, okay, let's write and so this is between t equal to 0 till t equal to 4, right? The velocity v is equal to dx by dt. So dx is change in x, right? How much x changes, but if you see, x initially is also 4, x final is also 4, so x is actually not going to change, right? So actually I'm supposed to calculate final value of x, that is x final minus x initial divided by time, so that is equal to 4 seconds. So this is no change by 4, so this is equal to 0. So velocity is 0 because it is not changing. So 0 to 4, the graph is 0. Okay, 0 to 4. All right, let's move further. next change is from at 4 there is a change, and that change continues till 10. Okay, so t is equal to 4 till t is equal to 10 is the next one. So t is equal to 4 to t equal to 10. Once again, v is equal to, find the final value of x. Final value of x is minus 8, that is over here at 10. Initial value will become 4. So it is right now 4, it becomes minus 8. So what is the total change? What's the total change? Final value is minus 8. Initial value is minus 4, right? Whole divided by. So difference, that is 10 minus 4, that is equal to 6. So this is minus 2 meter per second. So it's a constant value of minus 2. So I have to plot constant value of, say, minus 2. This is minus 2. It has to be minus 2 from this point. It actually goes till it is 10. Okay, next part, 10 to 14. So t is equal to 10 to t is equal to 14. So velocity is equal to the final value minus initial value, right? Final value is 0, initial value is minus 8. Okay, so 0 minus of minus 8 is plus 8 divided by 10 to 14, so 4. So that is equal to 2 meter per second. This is positive 2 meter per second. So if I mark this as plus 2, the resultant graph looks like this. So this is the required answer. This is time versus velocity. So velocity is a 0 for until 4 seconds because it is not moving. Then it is minus 2 constant, right, from 4 till 10. Then it is plus 2 constant from 10 till 40. Okay, this is the required answer for this particular question.